Muhammad Syami Faris bin Masya. My matric card number is CD150089. So for our project dynamic is a moment of inertia. So this is for introduction. Moment of inertia is the name given to rotational inertia, the rotational analog of mass for linear motion. It appears in the relationship for the dynamic of rotational motion. The moment of inertia must be specified with respect to a chosen axis of rotation. For a point mass, the moment of inertia is just the mass times the square of perpendicular distance to the rotation axis. I is equal to mr square. That point mass relationship becomes the basis for all other moments of inertia, since any object can be built up from a collection of point masses. So next is for the objective. Measure the dimension of the disk and its axis and representing a scale diagram of the disk. To calculate the moment of inertia of the system about its center of mass. To measure the angle of the slope. To measure the time required for the disk to travel 0.2 meter, 0.4 meter, 0.6 and 0.8 and 1 meter down the slope, and see the similarities between the theoretical and the experiment value. Next, the expression for the distance travel acts as function of time t. Last but not least, to sketch acceleration, velocity, distance graph as a function of time. Thank you.
Okay, Assalamualaikum. This is our procedure to study the theory of moment of inertia on a composite disk. So we can see here, this is our prototype we have been making. So this is our disk and the axle. The first one, for the procedure, we measure the diameter by using the vernier calipers. So the width of each axle and the disk was then measured and noted. Then the base of slope was measured, followed by the head. So the base of slope, this is the base. So by adding some book, we will adjust the head. For example, one book we'll consider as 0.2 and two book will consider as 0.4. Next, after measuring the composite disk, the disk and the slope and the disk was made to roll down a distance of 0.2, 0.4, 0.8 and 1 meter. Then, a stopwatch was used to record the time taken to the disk to roll this distance, and the disk was rolled thrice for each measurement. So this is example how the disk will roll down. So as we know, by adding a book as 0.2 meter height, we result the difference of velocity reading. This is the 0.2. Next, we will add some more book. So it will become 0.4. So 0.6. So 0.8. And 0. And 1.0. Assalamualaikum. My name is Muhammad Ashraf bin Zaidin. Matrix number CD180107. So for today, I will continue with the calculation for this project. The first thing we do to find out the mass. So we have three different value of mass. Next, after we able to find out the mass, we will find out the moment of inertia, which is the formula is 1 over 2 m r squared. So we have here the inertia of O, and the next thing we find out the calculation of time. Based on all the calculation we have been made, we recorded the result in the table and try to make a graph based on the result. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ajmal bin Mohtar and my matric number is CD108116. Okay, today I will continue with the graph analysis. In figure 7, show the distance as an equation of time is increased gradually. This is because the more the distance, the longer the time taken. Okay, next. Okay, I will continue with the graph velocity as a function of time. The graph increase linearly because the longer the time, the higher the velocity. Next, in figure 9, the graph show relation of accelerating as a function of time. The acceleration is constant since the angular acceleration is constant. Okay, lastly, the graph show the distance as a function of time and the value increase gradually as it's calculated theoretically. Okay, thank you. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ibrahim bin Azman. Entry number AD170123. And I will present about the discussion and conclusion. In discussion, we state that the